Hello everyone, welcome to my channel. So this is the 2024 NHT Maths Exam 1, question 5. So this is a non-calculator exam, and let's look at this question 5 here together. So let's read the information. In a nursery, 90% of the seeds will grow into seedlings. Let p hat be the random variable representing the sample proportion of seeds that will grow into seedlings for sample of size 100. Find the mean and standard deviation of p hat. So we need to, for A, we need to figure out the mean and the standard deviation of the sample proportion. So let us remember that in method, the expected value of p hat, the sample proportion, it will always be the population proportion. In that case, it will be 90%. 90% in this case, and that would be 0.9. I hope it makes sense. Again, the expected value of the sample proportion, it will be the population proportion, that is 90%. Now, next, the standard deviation, the standard deviation of p hat, the standard deviation of p hat, it will be, the formula has been given to us on the formula sheet, so let you use it. It will be square root of p 1 minus p divided by the sample size, that is n. If you are interested in knowing why we have the standard deviation of p hat equal to this, then please let me know. I can make another video explaining why. Okay, let's put in the number. So we will have square root of 0.9 times 1 minus p is 0.1 divided by 100, and this would give us 0.03. Now for part B, let z be the standard normal random variable such that z is normal 0, 1, and the probability that z greater than -1 is approximately 0.84. So this is one of the piece of information we need to analyze. So I will highlight it here. Okay, using a normal approximation of p hat, again, normal approximation of p hat, estimate the probability that in a sample of 100, more than 93 seeds will grow into seedlings. Give your answer correctly to 2 decimal places. So what does the question ask us? It is asking us to use normal approximation for p hat. So in year 12 probability, then we know that when the sample size is large, then the sample proportion is a random variable will approximately be distributed with normal distribution with the mean p, and standard deviation, it is the same as before, that is p times 1 minus p divided by n. Put them in the square root. Now, so let's put in a number. So in this question, our sample proportion here would be approximately normal with the mean 0.9, and as before, the standard deviation would be 0.03. Then what do the question want? They want us to calculate, we need to estimate the probability that a sample of 100 more than 90 seeds will grow into seedlings. So what does it mean? They want us to calculate the probability that p hat here will be out of the sample of 100, then more than 93 seeds will grow into seedlings. So the sample proportions of seed that will grow into seedling would be more than 93 over 100. That is 0.93. Okay, now here we face the problem. Usually for this question, if we want to calculate a normal probability other than the standard normal, we need a calculator. But this is exam 2, we cannot use it here. So therefore, we need to use this information that they have given us here. So we are required to calculate the probability that p hat is more than 0.93. Then how can we use this information? Firstly, we need to turn this probability into normal probability. So I will say here, turn p hat probability into the standard normal z probability. That is the step. Now, how can we do that? Okay, let's recall that this is very important, that if x distributed normal with mean mu and standard deviation sigma, right, then automatically x will be sigma multiplied with z, the standard normal, plus mu. Why is it the case? Because to obtain, okay, basically we can undergo a series of transformation and dilation to turn z, the standard normal, into x, where sigma would be the dilation factor and mu would be the translation. Okay, now, so because we know that our p hat will be distributed normal approximately with mean 0.9 and standard deviation 0.03. So what we can deduce is that p hat will be 0.03, that is the standard deviation, times z and plus 0.9. Does it make sense? So the probability that we want to figure out here, right? That one, let me call it as A. Then that probability can be, this probability here can be rewritten as the probability that 0.03z plus 0.9. Once again, this is just p hat, right? We want the probability of p hat to be more than 0.0, more than 0.93. Okay, so now thing is simpler. We can rearrange this inequality and turn it into the probability of z more than 0.93 minus 0.9. Take away this 0.9 here and then divide it both sides by 0.03. And this one, it would be 1. Does it make sense? So overall, we want to figure out the probability that z is more than 1. This is what we want. However, what we are given, when we look at the start of the question, what we were given is that, okay, this is what we were given here. We were given that the probability, based on the question information given before, the probability that z less than -1, right? That is approximately 0.84. This is what we are given. So we need to make a connection between what we want and what we are given, right, to answer the question. Then how can we do that? Then let's remember one thing. First of all, this probability here, right, it will be equal. It will be, okay, equal to the probability that z less than -1. Why? Because we have this formula due to symmetry. This formula is very important, especially for standard normal. So let us remember it. That is the probability that z, the standard normal, more than a, it will be the same as the probability that the standard normal less than -a. I hope it is understandable. So when we apply it in this situation, let me move it closer so that we can see. All right, let me move it here. Then our probability, the probability that we want is Z. Uh, okay, once again, the probability that we want is X is more than 1. It is the same as Z less than -1. See, what we do is we, from the greater than, we turn that sign into a less than, and then the number A, we turn it into -A. 1 turn into -1, right? And however, this is, okay, now, and what is the answer? Okay, I'm sorry, the information given was Z more than, sorry about that, Z more than -1 is 0.84. So we are one step away. This is what we want. We want Z that, we want the probability that Z is less than -1. And now this is what we are given. So what is the connection between them? Yes, we can use the complementary. The probability that Z less than -1, it will be 1 minus the probability that Z greater than -1. And that will give us 1 minus 0.84. That would be approximately 0.16. I hope it is understandable. So in this question, what is the key? First of all, remember that in VCE method, this formula about the expected value and the standard deviation of the sample proportion is always the same, and it is given in the formula sheet, so let's use it well. Also, for the second question, we need to be able to go, first of all, we need to establish that when we are allowed to use normal approximation, then the probability of p hat is approximately distributed with normal. The mean is always the same. It is always the sample. It is always the population proportion, and the standard deviation is always the same. Right. And then next step, it is just a matter of being able to convert between the probability of p hat into the probability of z so that we can answer the question. Okay, remember that when x is distributed normal with mean mu and standard deviation sigma, then automatically this is always true. I have to put the word always here. If as long as x is distributed with probability distributed with normal mean mu and standard deviation sigma, x will be can always be expressed and the can always be expressed in terms of z, like this is always true. So here we just need to sub this normal probability of p hat, right, turn it into the probability of z, and then so using the information given here. Okay, I hope it is clear. If you find this video helpful, please help to subscribe and also comment if you have any questions. Thank you so much for listening, everyone.